Hey everyone, today I'm gonna go over how you can add subcircuits or macro models to your LTspice schematic so you can use parts that aren't in the LTspice library. In today's example, we will be creating an active low-pass filter with an op-amp. However, this op-amp model is not within the LTspice library. There are several things that you need to do in order to import a model from outside of LTspice. The method I'm going to show you today will essentially allow you to import many different subcircuits or components just into one document. From there, all you need to do is add more models to this file, and whenever you need to use a specific part that's not in the LTspice library, you can just include this file in your schematic, and you will then be able to use this component. So first things first, we need to create a master file which will contain all of your LTspice models. So I already have it open here. However, I'm just going to go through it again. You go to Documents, and then you go to the LTspice version that you have downloaded. Currently, I have LTspice 17. Go into here. And then you go into Library, you go into Sub, and now in this directory you need to create your file. So, and it also has to be a .lib file. So that's what I'm gonna do really quickly. And for this example, I'm just gonna call it my macro models .lib. Also make sure that you delete it defaults to a text document, but make sure to save it as a .lib file. So I just create this file, and yes. So if you could just double click to open it, but then in order to edit this file, I need to open it in a text editor or just Notepad++. And I highly recommend using Notepad++ compared to just Notepad. It's just has more features and is more useful, in my opinion. And simply all you gotta do is drag and drop it into Notepad++. And I'm looking at my cheat sheet here. And essentially, like I mentioned, this file will contain all of your models. Now that we have this file created in this specific directory, now we just have to find the model of the component that we will be using. So since we are designing an active low-pass filter, we need an op-amp, and this op-amp, the op-amp model I will be using is going to be the TL084 op-amp. So what we're doing is just finding the LTspice or spice model of this specific op-amp, and to search for it, you just simply do a quick Google search, and there we go. So there are many sources you can get the spice model from. I just usually choose the first one, and it's actually from Texas Instruments. And just go down until you find the spice model. So once you find where you can download the spice model, just simply download it, and usually it gives you a zip file. So it's in my downloads file, and let's see. Once you download it, just simply extract this file that you've downloaded, which is also contains the LTspice macro models for this component. And this is essentially the file that you're kind of looking for. From time to time, the zip files can contain multiple files, but what you're looking for is just the spice model information of this specific component. And simply opening this so I can edit it or copy the contents, I just drag and drop it into Notepad++. And from here, what you do is just simply copy all the contents into the master file, your master file that you just created. And from there, if you see any black text, black highlighted text, just delete it. And I would also highly recommend to separate all of your models with asterisks. In LTspice, these asterisks are seen as comments, so they won't affect how LTspice reads this file. So now that we've copied the information over, all we need to do is you can exit out of the file that we downloaded, and we just need to save the master file that we created with the model inside. So now that we have the master file created, we can use this component. After saving the master file, now we just need to include this file in our schematic in order to use this subcircuit. And from there we can use this model of an op-amp for our simulation. So if I go to LTspice, which I already have up and running, if I create a new schematic, I'm going to be making the active low-pass filter in LTspice now. So this next step is very important, as you need to tell LTspice that where to find this model, because it can't find it itself. So in order to do that, we need to create a spice directive. And to open up this window, you can also simply just click this text icon up here, or you can press the hotkey T, which is the default hotkey in LTspice, and type .inc and the name of the file that you created, which in this case I named it mymacromodels.lib. And it's important that you add the file type in this line of code, or else LTspice won't be able to find this file. So just simply add it in the schematic. And that is essentially how you use this model, or utilize the model that we just obtained. So now, to actually utilize the model that we copied, and because it's an op-amp, I'm going to choose op-amp 2. So if you looking back, and this will be the model that will be used to represent the TL084 op-amp. And if you look back here it is actually a 5-terminal device, and op-amp 2 has 5 terminals as well: the positive and negative input pins, the positive and negative supply pins, and also the output. Make sure that you do not make the mistake of choosing op-amp, just simply op-amp, because this is a 3-terminal device and will not work with the spice model that we just imported. So it's very important that the pins match up with the model that you create. And if there is no model available for this component, you either have to create this schematic symbol yourself, or have LTspice automatically generate a symbol for you. So now that we have the right schematic symbol for the op amp that we are using, we with the correct model chosen, we need to also change some attributes to this LTspice symbol, the schematic symbol. So it is very important that you change the attribute prefix to capital X, and this essentially tells LTspice that you are using a subcircuit for this op-amp model, and this op-amp 2, it just happened to be X already. But it is important that when you're importing subcircuits that you change the attribute prefix to X. Next, so instance name, this is essentially just the name of the component, and it can be anything you want, or you just leave it alone, which personally I just leave it alone. And now you need to change the attribute value to the name of the Spice model that we just downloaded. So looking at our master file and the model that we're looking at, the name of the component is this text after the sub CKT or subcircuit, and it's important that you copy this and paste it into the attribute value in LTspice, and it will change like that. If you don't do that, then LTspice won't know to find this model and won't know what model you want to use. So it's very important that you do this as well. So essentially, now we've imported this component into LTspice, and we can finally use the op amp. So just quickly, using my cheat sheet here, I'm going to quickly draw up the active low pass filter. And I'm using hotkeys in order to quickly create this schematic. Kind of a bit of OCD here, that way there's space. So now we need to make after drawing up, so this is actually the LTspice, this is actually the filter itself. Let me label it. Actually move that right here. And this is actually VN. So these will be our power supply voltages. So I'm just going to go with -10 volts. My bad. 10 volts. In LTspice, all you have to do is simply label these nets with a value, and they will be the same whenever you use this name. It will be the same node. Essentially, they will be connected. So I'm connecting this negative 10 volts to the negative power supply of this op amp, and I'm connecting the V plus to the positive power supply of this op amp. So with this filter, low pass filter, active low pass filter, I'm also gonna want to generate a Bodhi plot from it. And essentially you need to perform an AC sweep, which is also the .ac operation. So you can come up here and click the .opt in order to create a spice directive. And the syntax, I'm just simply writing an AC sweep, a decade sweep from with 100 points in between each decade from 1 Hertz to 10 kilohertz. And this will generate a Bodhi plot of this circuit. So this has been designed to have a corner frequency of about 500 Hertz. So if we save, well, I didn't include an AC value for the input voltage. Right, so let me save this into a folder where I know where to find this. Let's see. I'm just gonna call it LTspice Workshop. Ah, there we go. So now, if I double click the output node, it should generate a Bodhi plot. So I'm just gonna not plot phase. And if I get the cursor and drag it to about -3 dB, which is also the corner frequency of this, because the base gain of this, low pass filter is 0 dB, so at the -3 dB mark, that is the corner frequency of this low pass filter. And if I go to about there, it's about 500 Hertz, which if you go through the AC analysis for this circuit, you will find that these values will give you a corner frequency of about 500 Hertz. So, and that pretty much ends this demonstration. I hope this video was helpful for you, and wish you the very best in your analog endeavors.